I've got the answers for the first three parts of problem one up here on the board so that you can check your work. And then I thought we'd go through the graphing together. So evaluating f of -3, I just made a note that because -3 is smaller than 1, I plugged into the top rule, and that gave me a 6. When I evaluated f of 1, that's the place where we change rules, but the bottom rule is the one that has the equal sign as part of the inequality. So I used the bottom rule. Cube root of 1 was just 1. And then when I plugged in 8, I was using the bottom rule again because 8 is bigger than 1. So the cube root of 8 gave me a 2. So now let's graph this together. So what I'm going to do is graph both functions, mark the pieces that I want to keep, and then put them together. It's not absolutely necessary to do that. Some of you might be comfortable going right to the final result. I kind of like to do it one step at a time, but it's a question of just how comfortable you are with it. All right, so I'm going to sketch y equals x squared minus 3. So that's just my basic parabola shifted down 3 units. And let's see where we are at 1. If I did plug in 1 here, I'd get 1 minus 3. That would be at -2. So I'm going to just put a hole there because I'm not using 1 for this rule. So the portion of the graph that I'm keeping is everything up to, but not including that point at 1, -2. Though I can label the location of a hole the same way I would label the location of a point. Now let's graph y equals the cube root of x. That looks very much like the cubing function except lying on its side more. So that was this function here, whoops, like so. Notice the part in the first quadrant looks very similar to the square root function. It's just going to be a little bit less steep because with the square root function, we get up to a height of 2 by the time we're at 4, whereas the cube root function, we don't get to a height of 2 until we're at an 8. Okay. But let's see. The point at 1 would be at 1. So here's a point 1, 1. And we're including that point, and then I want everything that's to the right of that. So now, if I put the pieces together to sketch f of x, I'm going to plot a hole at 1, -2, and then I've got this parabola with a vertex at 0, -3, and I'm going to have that the left side of that parabola. And then I'll have a point at 1, 1. That's a filled in point. And then we just follow the cube root function, which goes up and to the right, but is not very steep, to the right of that. So that's what that piecewise function would look like. Problem 2 was just to sketch this function, which came in 3 different pieces. So what I'm going to do is very similar to what I did when I had 2 pieces. I'm just going to sketch all 3 of these pieces, highlight the part that I want to keep, and then put those pieces together. All right, so I'm going to start with y equals x cubed. I know that's just my cubing function, which looks something like this. Looks like I'm going to have that if x is less than or equal to -1. So at -1, I know that -1 cubed is -1. So there's going to be a point here. And I'm going to make that a filled in point because I am including -1 in this part of the graph. So there's -1, -1. And I want everything that's there and to the left of there. So we're going to keep this piece of the cubing function. Now, if I sketch y equals 2x plus 3, that's just a line. The y-intercept is 3. Sorry, the y value of the y-intercept is 3. So the y-intercept is the point 0, 3. The slope is 2. Now I can write that as the fraction 2 over 1. So I'm going to count up 2 over 1 and connect the dots. using that between -1 and 1, not including the point at -1 because that's a strict inequality, but including the point at 1 because that's an inclusive inequality. So if I plugged in -1, I'd get -2 plus 3, I'd get 1. So it looks like there would be a point at -1, 1, but I'm going to draw that as an open circle. I'll draw that as a hole because we're not going to include that in our graph of G. At 1, if I plug in 1, I'm going to be at 2 plus 3, which is 5. So I'll have a point at 1, 5, and that one's filled in because it's an inclusive inequality. And then I wanted the part of the graph where x was in between -1 and 1. So it's going to be the middle portion of that line. Now, if I sketch y equals 1 over x, that's my reciprocal function. Looks something like this in quadrants 1 and 3. If x was 1, which is the cutoff location, the reciprocal of 1 is 1. I'm going to draw an open circle there. There's going to be a hole in the graph because I'm not including that particular point, but I'll keep this part of the graph to the right of 1. So now if I go to sketch g of x, it's going to have 3 parts to it. To the left of -1, we're following that cubing graph up until a point at -1, -1. So I'm just copying what I've highlighted in blue here. Okay. Then we jump up to a hole at -1, 1, and we're going to follow this line to a point at 1, 5. And that's a filled in point there. Okay. And then we're going to jump down to a hole. I probably should have labeled that was at 1, 1. Jump down to a hole at 1, 1, and we'll follow the reciprocal graph from there. Notice it's very important that when we jump, it's okay to jump from a point to a hole. It would be okay to jump from a hole to a point. I can't, though, have 2 points at the same x value. So it's important that each of these values where we change rules, I'm only using one of the rules. Okay? So that way we do pass the vertical line test. Certainly to the left of -1 we do, because we know we're just matching the graph of x cubed. But I need to make sure that we pass the vertical line test at those transition points, which means I've got only one y value associated with any given x. So if the rules are giving me different y values, only one of them is going to be a filled in point. The other is going to be an open circle. Now, it would be okay if this, for example, were a strict inequality so that I would have just a hole there. That would be fine. I can jump from a hole to a hole. That would just tell me that 1 was not in the domain because there was no rule for giving me a y value when x was 1. In this case, it is in the domain because I'm going to use that rule.